Good morning, dear students. Today we are going to discuss colloids. This module belongs to first BSc Chemistry in General Chemistry 1. So, what do you mean by colloids? The colloidal solution or colloidal dispersions are intermediate between true solution and suspension. The true solution and the suspension in between the solution is called as colloidal solution. So, another definition, it is a whole heterogeneous system in which one substance is dispersed as dispersed phase as very fine particles in another substance is called dispersion medium. When the dispersed phase and the dispersed medium are coagulated, we get colloids. The essential difference between a solution and a colloid is that of particle size. So, how do you differentiate the solution and the colloid means by using their particle size. While in a solution, the constituent particles are ions or small molecules. Okay, the solution, the particles may be ions or small molecules. But in a colloid, the dispersed phase may consist of particles of a single macromolecule. So, in colloids, the dispersed phase has single macromolecule. The diameter of the particles of a substances dispersed in a solvent ranges from about 10 Armstrong to 2000 Armstrong. So, the range of colloid in the diameter of the particle is 10 Armstrongs to 2000 Armstrong. So, next, what are the examples of colloid? In day-to-day life, we use more number of colloids for our daily life. They are milk, soap bubbles, ice cream, fog, butter, whipped cream. These are the common examples for colloids. Next, the classification. How do you classify colloids? The colloids can be classified based on the 5 points. So, what are they? It is classified based on nature of the dispersion phase and the dispersion medium. So, one is it depends upon the nature of the dispersed phase and the dispersion medium presence. Next, it is based on applications of colloid. Based on the uses, the colloids can be classified. Next, based on interaction of two phases, that means the interaction of dispersed phase and a dispersed medium, we can classify. Based on electrical charge, the charge of the colloids can be classified as another types. Last one, based on structure of colloids. By using the structure, we can classify the colloids. Next one, based on the nature of dispersion phase and the dispersion medium, it is classified into 8 types. Okay. So, when the dispersed phase is solid and the dispersed medium is solid, that name is called a solid sol. So, example for solid sol is alloys and glasses. Next one, dispersed phase is liquid, the dispersed medium is solid, then it is called as sol. The example for the sol is paint and ink. Next, dispersed phase is gas, the dispersed medium is solid, then it is called as aerosol. The example is dust and smoke. When the dispersed phase is solid and the dispersed medium is liquid, then it is called as gel. Example for the gel is jellies, cheese, etc. When the dispersed phase is liquid and the dispersed medium is also liquid, then it is called as emulsion. The example for the emulsion is milk and butter. Next one, the dispersed phase is gas and the dispersed medium is liquid, then it is called as liquid aerosol. Example for this type is mist and cloud. Next, when the dispersed medium is gas, the dispersed phase is solid, then it is can be called as solid foam. For example, foam rubber and cork is the best example for solid foam. The last type is when the dispersed medium is gas and the dispersed phase is liquid, that is called as foam. The example for foam is shaving cream or whipped cream. These are the examples on the basis of dispersed phase and the dispersed medium. Next classification, based on applications, it is classified into two types. So what are they? They are sol and gel. So what is meant by sol? When the dispersed phase is solid and the dispersed medium is liquid, then it is called as sol. The examples are paints and cell fluids. So next type is gel. So what is meant by gel? When the dispersed phase is liquid and the dispersed medium is solid, then it is called as gel. The examples we already seen, that the cheese and the jellies are the best example for gel. Next, the based on interaction of phases. Okay, when the two phases are interacting, we can classify the colloids by two types. They are lyophobic and lyophilic. So what is meant by lyophobic? It means liquid hating. That means it avoid the liquid. Substances like metals, their sulfides, when simply mixed with the dispersion medium, we get the lyophobic colloids. These salts are readily precipitated on the addition of small amount of electrolytes by heating or by shaking. These salts are also called as irreversible salts. That means it cannot be reversed, it cannot be recovered. Examples are dispersion of gold, iron 3 hydroxide and sulfur in water. When gold, iron hydroxide and sulfur are dispersed in water, we get lyophobic colloids. Next one, lyophilic colloids. It means the opposite one, that means liquid loving. Lyophobic means liquid hating, lyophilic means liquid loving. Colloidal salts directly formed by mixing substances with a suitable liquid. When the mixed substances are mixed in a suitable liquid, we get this type of colloids. This is also called as reversible salts. These salts are quite stable and cannot be easily coagulated. When the salts are prepared, this cannot be coagulated and it is very stable. So example for this type are dispersion of starch, gum and protein in water. When the starch, gum and protein are dispersed in water, they are very stable and cannot be easily coagulated. Next one, based on charge, the colloids can be classified into two types. So depending upon the charge of the colloid salt, that means when the colloid is in positive charge, then it is called as positive colloids. When the colloids are in negative charge, then it is called as negative colloids. So example for positive colloid is hemoglobin. The hemoglobin is an example for positive colloid. Gold salt and starch are example for negative colloids. So based on the charge, the colloids is classified into two types. One is positive and another one is negative. Next one, based on the structure. So the colloids can be classified into three types. One is multimolecular, another one is macromolecular and another one is micelles. So what do you mean by multimolecular colloids? Multimolecular colloids mean on dissolution a large number of atoms or smaller molecules of a substance aggregate together to form species having size in the range of 1 to 1000 nanometer. So on dissolution, large number of atoms or molecules combined together, okay, to form a species that the size is between 1 to 1000 nanometer. For example, when gold salt and sulfur salt are the best examples for multimolecular colloids. So what do you mean by macromolecular colloid? That is another one type. Macromolecules in suitable solvents form solutions in which the size of the macromolecules may be in the colloidal range. So next type is macromolecular. Macromolecular means when the macromolecules, the large molecules are dissolved in the suitable solvent, we get the colloids. Example for this macromolecular are starch and cellulose. The starch and cellulose are macromolecules. When they dissolved in the suitable solvent, we get macromolecular colloids. The last one is micelles. So micelles mean some substances at a low concentration behave as normal strong electrolytes, but at higher concentration it exhibits colloidal behavior due to the formation of aggregates. So what do you mean by micelles? Means some substances at low concentration, very low concentration, it behaves as normal electrolytes, but at higher concentration it exhibits as colloidal behavior. That is called as micelles. The example for micelles are soaps and synthetic detergents. The soaps and detergents are act as micelles. Next one, we are going to discuss about the preparation of colloid. So how do you prepare colloids? So the colloids can be prepared by two methods. The liophobic salts can be prepared by two methods. The lyophilic salts may be prepared by simple warming the solid with the liquid dispersion medium. For example, when starch, the solid, are dissolved in or warmed with the water, we get the lyophilic salts. So this is the simplest one. The liophobic salts cannot be prepared by this method. It can be prepared only by the special methods. They are dispersion or chemical method, dispersion and aggregation method or chemical method. So in this way we can prepare the liophobic salts. Next, the dispersion method. The dispersion method is classified into three types. They are mechanical dispersion, electrical dispersion and peptization. So what do you mean by dispersion method? In this method, a material in bulk is dispersed in other medium. So we can get a more number of colloids, more weight of colloids can be prepared by this method. So we take the reactants, material in bulk is dispersed in another medium. That is called as dispersion method. So what is meant by mechanical dispersion? The solid along with the liquid dispersion medium is fed into a colloidal mill. The solid along with the liquid, it is fed into a colloidal mill. The solid particles are ground down to colloidal size or then dispersed in the liquid to give the salt. The solid grind down into the colloidal size and then it is dispersed with the liquid to give the salt. The best example to prepare the colloids by this method are graphite and inks. Colloidal graphite and printing inks can be prepared by this method. Next one, electrical dispersion. So this method is used to prepare hydrosols of metal. When we take the metal as a solid dispersed phase, this method can be used. For example, when silver, gold and platinum salts can be prepared by this electrical dispersion. How do you carry out the electrical dispersion? Means the atoms of the metal present in the vapor aggregate to form colloidal particles in water. So when the metals are taken in the vapor form, it can directly form colloidal particles in water. Since the metal has been ultimately converted into salt particles, this method has been treated as of dispersion. So the metal can be easily converted into salt particles by this method. So this method is called as dispersion method. Non-metal salts can be made by suspending coarse particles of the substances in the dispersion medium and striking an ore between iron electrodes. So when we take the non-metal, so the non-metal can be prepared, non-metal colloids can be prepared by suspending coarse particle of the substances in the dispersion medium and strike to the iron electrodes, we get the non-metal salts. Next preparation, peptization. So what do you mean by peptization? Dispersal of a precipitated material into the colloidal solution by the action of an electrolyte in solution is termed as peptization. So that means the precipitated material into a colloidal solution by the action of electrolyte, okay, that is called as peptization. The electrolyte used in this process is called as peptizing agent. So some of the examples for peptization are preparation of silver chloride, ferric hydroxide salts are the best examples for peptidization. Next, chemical methods. So, the chemical methods is classified into 5 types. This is also called as aggregation method. This method consists of chemical reactions or change of solvents whereby the atoms or molecules of the dispersed phase appearing first to form colloidal particles. So, this is nothing but the chemical reactions or change of solvent that can be carried out by using the dispersed phase. We can get the colloidal particles. What are the 5 methods? They are oxidation, reduction, double decomposition, hydrolysis and change of solvent. So, first one, oxidation. So, what is the example for oxidation reaction means? A sol of sulfur is produced by passing hydrogen sulfide into a solution of sulfur dioxide. A sulfur salt can be prepared by passing the sulfur dioxide using hydrogen sulfide. We get the sulfur salt as precipitate. Next type, reduction. By using this method, we can prepare silver and gold salts. So, silver and gold salts can be obtained by treating dilute solution of silver nitrate or gold chloride. When we want gold salt means we can use gold chloride. When we want silver means we can use silver nitrate. The silver nitrate or gold chloride with the organic reducing agent like tannic acid of methanol. So, by using this tannic acid with the silver nitrate and gold chloride, we get silver and gold salts respectively. Next, by hydrolysis. How do you prepare colloids by using hydrolysis? Salts of the hydroxide of iron, chromium and aluminium are readily prepared by the hydrolysis of salts. When we hydrolysis the salt, we can get the hydroxides of iron, chromium and aluminium. Next method, double decomposition. So, what is meant by double decomposition means? Example for this type is when arsenic sulfide salt is prepared by passing a slow stream of hydrogen sulfide gas through a cold solution of arsenious oxide. When we have to prepare the cold solution of arsenious oxide, we have to pass a slow stream of hydrogen sulfide gas. This process is continued till the yellow color of the salt attains maximum intensity. That means the yellow color has the highest intensity that means the arsenic sulfide salt is prepared. Now that in this stage we can stop the passing the hydrogen sulfide gas. Last one, change of solvent. When a solution of sulfur or resin in ethanol is added to an excess of water, the sulfur or resin salt is formed owing to decrease in solubility. Next, the change of solvent can also used to prepare the change of solvent can also used to prepare the colloidal solution. How do you prepare? When a solution of sulfur or resin in ethanol is added to an excess of water, we can get the sulfur or resin salt. These are the preparation methods to prepare colloids. Last one, applications. So, what are the applications of colloids? A colloid is used as thickening agent in industrial products such as lubricant, lotions, toothpaste, coatings, etc. So, when you prepare lubricants, lotions, they may be face lotions or creams, etc. By preparing toothpaste, for preparing coatings, we can use this colloid as thickening agents. Next, in the manufacture of paint and inks, colloids are useful. Already we discussed the type of examples. The paint and inks are the best example. So, that is also the colloid. Next, most of the medicines are colloid. Almost all the medicines are colloids. For example, colloidal gold and the calcium are injected into the human body for the vitality of the muscles. When we take the colloidal gold and the calcium that is injected into the human body, it is used for the vitality of the muscles. Next, silver salt is used as an eye lotion. For our eye contacts or eye deficiency diseases, we can use silver sol. Next, albumin and HETA starch and dextrin can be used as medicinal purpose. These are the applications of colloids. So, in the next module, we shall discuss the properties of colloids. Thank you, girls.